Sorting is an arrangement of data in a particular order. But if we talk about sorting in data structure, then it is more relevant to rearrange the data or element in ascending or descending order, which can be lexicographical, numerical, or maybe user-defined. For example, consider you have 5 siblings and you want to arrange them according to height. Now, if you wish to arrange them in increasing or decreasing order of height and then algorithm, you will perform to do this task is sorting. But more interestingly, in how much time you can do it. Suppose if you do it in 5 sec and when your sister is given a chance and she does it in 3 sec, then her idea would be the best among both of you. And that's the complexity of your algorithm. There are many sorting techniques defined in computer science domain like bubble sort, insertion sort, selection sort, quick sort, med sort, radix sort, bucket sort, etc. In this video, we will be focusing on bubble sort. Without any further ado, let's get started. What's in it for you are, first we will see what is sorting in data structure and why sorting is important in data structure. Next, the categories of sorting in data structure. Also the types of sorting algorithm in data structure. Next, we will move to the core topic, what is bubble sort. After that, we will see how does the bubble sort work. Along with that, we will see the bubble sort algorithm. And next, we will see the pseudocode for bubble sort algorithm. After which, we will see the Python code which implements the bubble sort algorithm. And then we will see how to implement the bubble sort in C programming. Thereafter, we will see the algorithm for optimized bubble sort. After that, we will move on and understand how to implement the optimized bubble sort in Python as well as in C programming. Following this, we will see the complexity of bubble sort algorithm. Thereafter, the advantages and disadvantages of bubble sort. And finally, the applications of bubble sort algorithm. First, what is sorting in data structure? The arrangement of data in a preferred order is called sorting in data structure. By sorting data, it is easier to search through it quickly and easily. The simplest example of sorting is a dictionary. Sorting is the process of arranging items in a specific order or sequence. It is a common algorithmic problem in computer science and is used in various applications such as searching, data analysis, and information retrieval. In other words, you can say that sorting is also used to represent data in more readable format. Some real-life examples of sorting are contact list in your mobile phone and keywords in your book. The contact list in your mobile phone also contains all the contacts arranged alphabetically. So if you look for a contact, then you don't have to look randomly and it can be searched easily like many other apps on your phone. Similarly, keywords in your book are also in lexicographical manner and you can find it according to the chapter. Now let's see why sorting in data structure is important. When you perform sorting on an array or elements, many problems becomes easy. For example, to find the largest or smallest number between two numbers, or to find the smallest or largest element of the given array. Performing sorting also gives number of algorithmic solutions that contain many other ideas such as iterative method, divide and conquer method, comparison and non-comparison based approach, and recursion method. The main advantage of sorting is time complexity, and that's the most important thing when you solve a problem. Because it's not enough you are able to solve a problem, but you should be able to solve it in the minimum time possible. Sometimes problems can be solved easily and quickly based on sorting, which can prevent you from every coder's nightmare, that is time limit exceeded. Now let's see the sorting categories in data structure. The sorting categories in data structure can be broadly classified into following types, that is comparison based sorting algorithm, non-comparison based sorting algorithms, stable sorting algorithms, unstable sorting algorithms. Talking about comparison based sorting algorithms, these algorithms compare the elements being sorted to each other and then place them in a desired order. Examples include bubble sort, selection sort, insertion sort, quick sort, merge sort, and heap sort. Next, the non-comparison based sorting algorithms. These algorithms do not compare the elements being sorted to each other. Instead, they use some specific characteristics of data to sort them. Examples include counting sort, radix sort, and bucket sort. Next are the stable sorting algorithms. These algorithms maintain the relative order of elements with equal keys during sorting. Example includes merge sort and insertion sort. At last, we have unstable sorting algorithms. These algorithms do not maintain the relative order of elements with equal keys during sorting. An example includes quick sort and heap sort. And next we move on to the types of sorting algorithms. Although there is number of sorting algorithms, the best algorithm is which can solve a problem in a minimum time and minimum space required to do so. And some types of sorting algorithms are listed here. The bubble sort algorithm is the most basic among all of this. Now let's move to the core topic. What is bubble sort? Bubble sort is a sorting algorithm that compares the adjacent elements repeatedly and swaps them if they are out of order until the entire array is sorted. Just like the movement of air bubbles in the water that rise up to the surface, each element of the array moves to the end in each iteration. Therefore, it is called bubble sort. So depending on the order of sorting, that is if you want to sort in increasing order, then the larger elements will move toward the end. And if it's decreasing order, its smaller elements will move towards the end. Now let's move on and understand the working of bubble sort algorithm. The bubble sort algorithm is also known as sinking sort. Also, it is the simplest sorting algorithm that runs through the list repeatedly. And it compares the adjacent elements and swaps them if they are out of order. The process of traversing the list is repeated until the list is sorted. The comparison sort algorithm is named after smaller or larger elements bubble at the top of the list. And this figure depicts the real-time implementation of bubble sort. Bubble sorting is accomplished by recursively comparing the adjacent elements and shifting them in ascending or descending order. Let's assume an array. Now we are going to arrange the elements in ascending order. Here array contains 5 elements. That means you must perform 4 comparisons for the most significant element to bubble to the top of the array. Then why do we do 4 comparisons? Here n is the number of elements in the array. N minus 1 is the number of times the comparison occurs. Therefore 5 minus 1 equals 4. And thus we need 4 comparisons. Now let's iterate through the list. Firstly, bubble sort starts at the beginning of the list, so it compares the first 2 elements. To compare the first and second elements, we start with the first index. They are swapped if the first element is greater than the second. And here we switch 7 and 2 because 7 is greater than 2. Now compare the second and third element. If they are not in the correct order, swap them. And here we are going to compare 7 and 9. No swapping is required because 7 is less than 9. And this preceding procedure is repeated until it reaches the final element. So at the end of the first iteration, the first largest element is placed in its correct position. That is in the end of the array. And next in second iteration, we're gonna place the second largest element at the correct position. Now we compare the first and second element in the array. Here no swap is required because 2 is less than 7. Again compare the second and third element. Here we swap the element because 7 is greater than 6. And repeat the process. Now we compare the third and fourth element and we swap the both elements because 7 is greater than 4. And we repeat the process for the remaining iterations. So the most significant element among the unsorted elements is placed at the end of each iteration. So at the end of the second iteration, we place the second largest element at the correct position. Next, we need to place the remaining 2 elements at their correct position. Now compare the first and second element and no swap is required because 2 is less than 6. Now compare the second and third element. Here we swap because 6 is greater than 4. When all the unsorted elements are placed in their correct position, the array is sorted. Now the array is sorted and all the elements are kept in right order. The principles of bubble sort algorithm can be summarized in the following steps. Compare the first and second elements in the list. If the first element is larger than the second, swap them. And then move on to the next pair of elements and repeat the process. Continue doing this until you have gone through the entire list without having to make any swaps. At this point, the list is sorted. In algorithm, we have a list which is an array of n elements. And further, we have a swap function which will swap the value of a given array elements. Now observe the algorithm. Here we compare each pair of array elements unless the whole array is completely sorted in an ascending order. This may cause some complexity issues, like what if array needs no more swapping or if the elements of the array is already swapped. To ease out this issue, we use one flag variable called swapped. And this swap variable will help us to see if the swap has happened or not. If no swap has occurred, that is if array requires no more processing, it will come out of the loop. And here is the basic pseudocode for bubble sort algorithm. First, create a function that takes an array or list of elements as an argument. Next, get the length of the list. Now create a loop that repeats until no more swaps are needed. And then create an inner loop that steps through the list, comparing each pair of adjacent elements. If the elements are in wrong order, swap them. Set a flag swap to true if any swaps were made during the inner loop. After the inner loop, if the swapped flag is false, the list is sorted and you can break the outer loop. And repeat the inner and outer loops until the list is sorted. And at last, return the sorted list. Now let's go through the pseudocode line by line. This line defines the bubble sort procedure. It takes a list of sortable items as input and returns a sorted list. This line initializes the variable n to the length of the input list. and this line starts the main loop of bubble sort algorithm. The loop will continue until the list is sorted, and this line initializes the variable swapped to false, and this variable will be used to track whether or not any swaps were made during the current iteration of the loop. And next line starts a for loop. Here we initialize the loop that iterates to the list A from index 1 to index n-1. And we know that for loop is a control structure that allows a block of code to be executed repeatedly. Here the loop variable I is initialized to 1, and it is incremented by 1 after each iteration of the loop. The loop continues until the value of I is greater than or equal to n-1. Here the loop iterates through the list A from beginning to the end, which will compare the adjacent element and swap them if they are in the wrong order. So the loop continues until the list is sorted. At that time the swapped variable will be false and the loop will terminate. This line of code will check if the element at index I-1 is greater than the element at index I in the list A. The greater than symbol is the greater than operator, and it returns true if the left hand operand is greater than the right hand operand. Otherwise it returns false. And here we determine if the two adjacent elements at indices I-1 and I are in wrong order. If the element at index I-1 is greater than the element at index I, then the two elements are in the wrong order and need to be swapped. And this line of code swaps the value of two elements at indices I-1 and I in the list A. This line of code sets the swapped variable to true, which indicates that a swap has occurred. Together, these two lines of code implement the swapping operation, which is the heart of the bubble sort algorithm. By repeatedly swapping the adjacent elements that are out of order, the bubble sort algorithm gradually moves the larger element to the end of the list, which results in a sorted list. And this algorithm continues until no more swaps are needed. And these lines of code provides the end of the bubble sort algorithm. The end statement at the end of the code closes the if statement, which will also check if the swapped variable is true. If the swapped variable is true, then the algorithm will continue to the next iteration of the outer loop. If the swapped variable is false, then the algorithm will exit the outer loop and the sorting process will be complete. And this line ends the for loop. And in this line we check if the swapped variable is false. If it is, then the loop will stop iterating. The end procedure line ends the bubble sort procedure. Now let's see the Python program to implement bubble sort. First we define a function called bubble sort, which takes an array as input, and it will return the sorted array. And this line starts the outer loop of bubble sort algorithm. The outer loop iterates through the array from beginning to the end, excluding the last element. And this line of code is the inner loop of the bubble sort algorithm. The inner loop iterates through the array from beginning to the end, excluding the last I elements. And this line of code will compare the current element of the array with the next element. If the current element is greater than the next element, then two elements are swapped. And this line of code swaps the two elements if the current element is greater than the next element. And finally, this line will return the sorted array. And now we call the bubble sort function and we pass the array. The bubble sort function then sorts the array and returns the sorted array. The sorted array is then stored in the sorted array variable. And this line prints the sorted array. That is the output of the code. Now let's execute the program. And you can see the output, which is in ascending order. Now let's see the C program to implement the bubble sort. These two lines include the stdio.h and stdlib.h header files. The stdio.h header file contains the functions for input and output, while the stdlib.h header file contains the function for memory location and other general purpose functions. And here void is a keyword, which indicates that the function does not return a value. Here the swap function is declared with void return type, which means the swap function does not return a value to the caller. So the swap function will simply swap the value of two integers that are passed to it as arguments. Now let's see how it works here. The swap function takes two pointers to integers xp and yp. And the function dereferences the pointers xp and yp to get the values of the integers that they point to. And next the function stores the value of the integer that xp points to in a temporary variable called temp. The function stores the value of the integer that yp points to in the location that xp points to. Also the function stores the value of temp in the location that yp points to. And at last the function returns. After the swap function has been called, the values of the integer that xp and yp points to will be swapped. And here the function sorts an array of integer using bubble sort algorithm. The function takes two arguments, a or r and n. A or r is an array to be sorted, and n is the number of elements in the array. And this function sorts the array in ascending order. The function bubble sort first initializes two variables, is I and j to 0. Then the for loop iterates through the array, which will start at index 0 and ends at index n minus 1. For each value of I, the for loop iterates through the array from index 0 to index n minus I minus 1. If the element at index j is greater than the element at index j plus 1, then the two elements are swapped. And this function continues to iterate through the array until no more swaps are made. When the function terminates, the array will be sorted in ascending order. In this block of code is the entry point of the program. Int main is the beginning of the main function. The main function is the entry point of the program where the program execution begins. And next we declare an array of integers named ARR. The array is initialized with the values 64, 34, 25, 12, 22, 11 and 90. Next we declare an integer variable named n. And we initialize it to the size of the array ARR. Here the size of operator returns the size of the data type in bytes. In this case the size of an integer is 4 bytes. Next we declare an integer variable named I. And then we call the bubble sort function. This function takes two arguments, that is the array to be sorted and the size of the array. Now the for loop that iterates through the array ARR, the loop will iterate from I equals 0 to I equals n minus 1. And then we print the value of element at index I of array ARR. And this line returns 0 from the main function, which indicates the program has been terminated successfully. Now let's execute the C program. And you can see the elements of the array is being sorted in ascending order. Now let's see the optimized bubble sort algorithm. In the previous algorithm, all the comparisons are made even if the array is already sorted. And that increases the execution time. To solve this, we can introduce an extra variable swapped. The value of swapped is set to true if there occurs swapping of elements. Otherwise, it is set false. That is, after an iteration, if there is no swapping, the value of swapped will be false. This means elements are already sorted and there is no need to perform further iterations. And thus, this will reduce the execution time and helps to optimize the bubble sort. And here is the algorithm for optimized bubble sort. There are several reasons why we might want to optimize the code. First is efficiency. Optimization can make code run faster and use less memory, which can improve the performance of a program. Next, scalability. Optimization can help a program scale to larger datasets or more users without experiencing performance problems. Next reason is reliability. Optimization can help to make a program more reliable by reducing the risk of errors. And next, maintainability. Optimization make code easier to read and understand, which can make it easier to maintain and update. And the next reason is cost. Optimization can reduce the cost of running a program, especially if it is used on large scale. Now let's see the optimized code for bubble sort algorithm in Python. In the case of bubble sort algorithm, the optimized version is more efficient than the original version. This is because the optimized version stops iterating to the list once it is sorted, which can save a significant amount of time if the list is already sorted or nearly sorted. Now let's go through the code. The bubble sort function is defined. It takes an array as input and returns the sorted array. The variable n is assigned the length of the array. Next, the swap variable is initialized to true, which indicates that the array is not sorted. The while loop continues until the swap is false, which means the loop will continue until the array is sorted. Next, the variable swapped is set to false. This indicates that no swaps have been made in this iteration of the loop. Next, the for loop iterates through the array from the index 0 to n minus 1. If the current element is greater than the next element, then the two elements are swapped. Here two elements are swapped by assigning the value of array I plus 1 to array I and the value of array I to array I plus 1. Next, the variable swapped is set to true, which indicates that the swap has been made in this iteration of the loop. And this line returns the sorted array. And next, we call the bubble sort function with the input array and stores the sorted array in the variable sorted array. And finally, we print the sorted array. Now let's execute this program. And you can see the array is sorted. Okay, now let's see the optimized bubble sort in C program. In this optimized code, we don't use a function called swap. Instead, we use a series of assignment statements to exchange the values of two variables. This line includes the stdio.h header file, which contains the functions for input and output. And next line includes the stdlib.h header file, which contains the functions for memory allocation and other general purpose functions. And next we declare the bubble sort function, which takes an array of integers ARR and its size n as input parameters. Then we declare two integer variables, that is I and j. Next we initialize for loop. It will iterate n minus 1 times, where n is the size of the array. This loop will start with I equals 0 and it will continue until I is equal to n minus 1. This loop contains another for loop which will iterate n minus I minus 1 times. So this loop starts with j equals 0 and it will continue until j is equal to n minus I minus 1. The loop body contains an if statement which will check if the current element of the array is greater than the next element. If this is the case, then the two elements are swapped. And these lines of code will swap the values of two adjacent elements in an array. First, we create a temporary variable called temp and we assign it a value of the element at index j in the array. That is, this line will store the current element of the array in a temporary variable. The second line then assigns the value of element at index j plus 1 in the array to the element at index j. That is, this line will replaces the current element of the array with the next element. Next, the third line then assigns the value of temporary variable temp to the element at index j plus 1 in the array. That is, this line replaces the next element of the array with the temporary variable. And next we ends the if statement. Along with that we ends the nested for loop. And next up we ends the for loop. And this part of code is the main function of the program. Here we initialize an array of integer called ARR with some values. Then we calculate the size of the array by dividing the total size of the array by size of each element. The program then calls a bubble sort function to sort the array in ascending order. Finally, the program prints out the sorted array using a for loop. The line int main declares the main function, which is the entry point of the program. And next we declare an array of integer ARR and we initialize it with the values 64, 34, 25, 12, 22, 11 and 90. And next we calculate the size of the array ARR by dividing the size of the array by the size of each element. Next declare the integer variable I. Next call the bubble set function with array ARR and its size n as input parameters. Next we initialize the for loop that will iterate n times. Then we print the current element of the array to the console. And next we end the for loop. And lastly we end the main function. Now let's execute this program. And you can see the given elements are sorted in ascending order. Now let's analyze the complexity of an algorithm. An algorithm's complexity is a measure of how long an algorithm would take to complete a given input of size n. If an algorithm has to scale, it should compute the result within a finite and practical time bound, even for large values of n. For this reason, the complexity is calculated asymptotically as n approaches infinity. While complexity is usually in terms of time, sometimes complexity is also analyzed in terms of space. To be simple, algorithmic complexity is also called as complexity or running time. The analysis of algorithms complexity is helpful when comparing the algorithms or seeking improvements. Algorithmic complexity falls with a branch of theoretical computer science called computational complexity theory. And it is important to note that we are concerned about the order of an algorithm's complexity, not the actual execution time in terms of milliseconds. So the complexity of an algorithm computes the amount of time and space required by an algorithm for an input of size n. And it can be divided into two types, that is time complexity and space complexity. The time complexity of an algorithm describes the amount of time an algorithm takes to run in terms of characteristics of input. In other words, we can say the time complexity is an approximation of total number of elementary operations executed throughout the program. The elementary operations includes the arithmetic or bitwise instructions, memory referencing, control flow, etc. And these elementary operations take a fixed amount of time to perform. The time complexity for the original version of bubble sort algorithm is order of n square. And this is applied to all the cases, including the worst, best and average cases. Even if the array is already sorted, the algorithm does not check that at any point, and it will run through all the iterations, whereas the number of swaps would differ in each case. Now let's analyze the time complexity of optimized bubble sort algorithm. The worst case complexity of bubble sort algorithm is order of n square. This is the case when array is reversely sorted. There is in descending order. What we require is ascending order. So the number of swaps of two elements is equal to the number of comparisons. Therefore, in worst case, the number of comparisons and number of swaps is order of n square. The best case time complexity of bubble sort algorithm is order of n. This case occurs when the given array is already sorted. Therefore, in best case, the number of comparisons is order of n and number of swaps is order of 1. The average case time complexity of bubble sort algorithm is order of n square. In average case, the array is partially sorted. And the algorithm has to make n by 2 passes through the array, with each passes requiring n by 4 swaps on average. And this results in the total of n into n by 8 swaps, which is order of n square. Therefore, in average case, the number of comparisons is order of n square and number of swaps is order of n square. First, we will see the worst case and then we will come to the best case. So, imagine if I have an array like this. I have taken the snippet so that we can better analyze this. And in this structure, I have a loop. And this internal loop will run if I compare these two elements. If the left element is greater than the right element, I keep swapping. So, in the first iteration, if I have n elements, then I can have n comparisons. Also, at most n swaps. That is, I could have at most n swaps. In second iteration, I am running this for loop. And now the largest element is already moved. That is, the largest element is already bubbled to the right. And in this iteration, I have n minus 1 comparisons and n minus 1 swaps. Now in third iteration, I could have n minus 2 comparisons and n minus 2 swaps. In worst case scenario, we can have the maximum number of comparisons and swaps. So the loop could run n number of times. Because at the end of the first time, the largest element will be moved here. While running the second time, the second largest element will be moved here. So I will be keep doing this till all the rest of the elements are taken care and only one number is left. So I will have n plus n minus 1 plus n minus 2 and so on. And if I keep summing the swaps, I will have n into n minus 1 by 2. So this is basically if you have n numbers. For example, if you have 3 numbers, that is 1, 2 and 3. On simplifying this, we get 12 by 2, which is 6, which is nothing but order of n square. Because of this structure, that is where you can have at most n comparisons in first iteration. The worst case complexity is order of n square. And what about the best case? In best case scenario, the array is already sorted. For example, if I have an array with elements 2, 3, 4 and 7, here the array is already sorted and my swap will be false. I'm comparing these two elements, but I'm not swapping. Again I compare these two, but I don't swap. And once again I compare these two and I'm not swapping. And I don't swap throughout this loop. So the loop get terminated because I initialize the swap to false. And if the left element is greater than the right element, at least once the swap may become true. So what's happening here? If my array is already sorted, I would make at most n comparisons and no swaps. There is constant number of swaps or 0 swaps. So this is the best case, right? Here the array is already sorted. So here I don't know the upfront until I run the whole algorithm. So in the best case, I have order of n comparisons and order of 1 swaps. Most of the time we have been told that the complexity of bubble sort algorithm is order of n square, and it is not that. And this is the common mistake we often do because we don't have the slightly optimized implementation of bubble sort. So for the best case, we have order of n, and for worst case, we have order of n square. And now let's assume an array that is not properly sorted. There is somewhere in between the sorted and unsorted array. And this is called average case. In worst case, the array will be sorted in the descending order. In the best case, the array is sorted in the ascending order, and that is what we want. So in the average case, the array is neither in ascending order or descending order. In the average case, time complexity is order of n square and swaps also order of n square. So when does the worst case happen? If the input is in descending order and we want to sort in ascending order. The best case happen, the given input is ascending order, and that's the array we want. And the average is somewhat in between these two. These nuances are very important, and you can never say the time complexity of bubble sort is order of n square. You have to say the worst case is order of n square. And next, the space complexity. And the space complexity is the total number of memory used by an algorithm for complete execution. It includes both the auxiliary memory and the input. The auxiliary memory is the additional space occupied by an algorithm apart from the input data. And here we have an array A. Apart from array, we have the variables swapped. We have an intermediate variable swap. Also we have a variable I. So to swap two elements, that is left element and right element, we use a variable swap. Here the left element is A of I, the right element is A of I plus 1. So we need to create 3 variables. So the space complexity is order of 1, which is the constant value. So the order of 1 is the constant complexity. It takes the same amount of space regardless of input size. And thus the bubble sort requires only the fixed amount of extra space for flag, I and size variables. As a result, the space complexity of bubble sort will be order of 1. This algorithm is an in-place sorting algorithm which modifies the original array element to sort the given array. Now let's see the advantages and disadvantages of bubble sort. Bubble sort algorithm is easy to understand and implement as it is made up of only few lines of code. Besides the memory that the array or list occupies, the bubble sort requires very little memory. That is, it does not require any additional memory space. This algorithm is simple to implement. This algorithm works well for small data sets and it requires only constant space. The bubble sort algorithm is an example of stable sorting algorithm since it preserves the relative order of element with equal keys. Talking about the disadvantage of bubble sort algorithm, the amount of time it takes is more. The fact is it does not deal well with the list containing huge number of elements. And its worst case time complexity is order of n square. Due to the high number of swaps, it is expected to generate twice as many write operations and twice as many catch misses. Therefore, we don't prefer this algorithm for an ordinary sorting job. The bubble sort algorithm is comparison based algorithm, which means it requires a comparison operator to determine the relative order of an element in the input data set, so that it can limit the efficiency of an algorithm in certain cases. Now let's see the bubble sort applications. It is used in sorting of cards in a deck of cards and to sort the books in library. And it is used in sorting of files on computer and it will sort the numbers on phone dialer. Also it is used to sort the items in a shopping cart. Let's see some real-time applications of bubble sort algorithm. It is used for teaching purposes. Bubble sort algorithm is one of the most simplest algorithm which is easy to understand and implement. And it is a popular choice for teaching introductory computer science courses. Next, it is preferred for small data sets. We know that bubble sort is slow performance, but it is not a significant issue. But its simplicity makes it an ideal choice for quickly sorting a small amount of data. And with bubble sort, we can verify the other sorting algorithms. That is, the bubble sort can be used as a verification step in testing the other sorting algorithms. Using bubble sort algorithm, we can check the data validity. The bubble sort is the simplest way to check the input data is in correct order before the most complex algorithms are applied. Also, it is used in custom sorting needs. Moreover, bubble sort is an ideal choice when sorting is based on multiple criteria or sorting data that has a complex dependencies. And so far we have learned everything there is to know about the bubble sort algorithm, including how to implement it and how to use it. And that's all for this session. Thank you so much for watching.